Here's a script fetching 100 URLs. Request 1 goes out and everything stops. The CPU is idle, just waiting for a reply. Only once it returns does request 2 even start. 100 requests, one at a time, 99 seconds wasted. I'm kind. If your CPU is sitting idle, why does your code still take 99 seconds? That's the question we're answering today. And it's plain Python you already write, no distributed systems background needed. The obvious fix, spin up 100 threads. Now every request waits at the same time instead of one after another, but each thread costs real memory and OS overhead. Try 10,000 requests and 10,000 threads will crush the machine. Asyncio does it differently, one thread, one loop. It kicks off request 1, then immediately checks, is anything else ready? While request 1 waits, it starts request 2, then request 3. The loop keeps cycling through tasks, running whichever one isn't currently waiting. No new threads, no new memory per request, just one loop juggling everyone's downtime. You mark a function async def when it's going to pause without blocking the whole program. Notice main is async too. That's not optional. You can only use await inside another async function. So the asyncness has to run all the way up the call chain, from main down to fetch. Await doesn't mean wait here and do nothing. It means I'm waiting. Go run someone else while I do. That handoff back to the loop is the entire trick. Quick question. Worth pausing on. When Asyncio gather fires off 100 requests and one of them times out, does it kill just that task or does it take the other 99 down with it? Take a guess and drop it in the comments. The code coming up next settles it. Instead of looping and waiting on each URL one by one, you build a list of tasks first. One fetch call per URL, none of them running yet. Asyncio gather starts them together and the await underneath waits for the whole batch. Now, back to that guess. If one request times out, gather raises that exception right away. But it does not cancel the other 99. They keep running in the background unless you cancel them yourself. Want failures collected instead of raised? Pass return exceptions equals true and gather hands you the exception objects alongside the successful results. Rough order of magnitude, your exact numbers will vary by network and hardware. Sequential lands around 100 seconds since each request waits its turn. Threading cuts that down to single digit seconds but eats memory per thread. Async gets you into the same single digit range on one thread, no extra memory per request. The shape of the win matters more than the exact seconds. Ask async to crunch numbers instead of wait on a network and it gives you nothing. One task hogging the CPU blocks the whole loop. There is no waiting to hand off during. Async wins when the bottleneck is waiting. Threads or multiprocessing win when the bottleneck is computing. Your CPU was never the bottleneck, waiting was. Asyncio doesn't make requests faster, it makes waiting free. One loop, 100 tasks, 98 seconds back. Missing something or got a request? Drop it in the comments.